Hello student, very good morning to all of you. How are you? I hope you all are happy, healthy and fine at home. Do you remember what were we discussing yesterday? I think we were discussing about the application of IR spectroscopy. And in that we have discussed the first application of the IR spectroscopy. And as we know that according to the statement of spectroscopy or the definition of the spectroscopy, simplest definition, the interaction of electromagnetic radiation with matter is known as spectroscopy, and IR spectroscopy is corresponding to functional group. Means from IR spectroscopy we can identify the functional group present in the organic compound. There are the different functional group, and that different functional group absorb at a specific functional group. That are the characteristic of that functional group absorbed at a definite. And in some cases, the shape and the size of that peak doesn't change, but the position of that peak or signal is sometime is shifted either higher or the lower side due to the presence of such as inductive effect, resonance effect, hydrogen bonding or steric effect. These are the factors responsible for shifting the IR peak value either lower side or the higher side depending upon such factor. Those factors I have just mentioned right now. Now today what we are going to discuss, look at the board. What is written? Application of IR spectroscopy. First application we have discussed the determination of structure. In the determination of the structure with respect to the following points: number one, functional group region. Second one is a fingerprint region. Third one is a aromatic region. How these regions are helpful for identifying the specific functional group in the organic compound. And that are the first application we have seen. And the second application which we are going to discuss, the study of progress of chemical reaction. Second one, study of progress of chemical reaction. Study of progress of chemical reaction. What do you mean by study of progress of chemical reaction? Study or the analysis. Progress means, suppose you take any reaction in the reaction container or generally in the round bottom flask, where the appropriate amount of starting material, add the necessary reagent and keep the appropriate reaction condition, whether that reaction carried out at room temperature or it require higher temperature, at reflux condition, some of the reaction even occur at lower temperature than the room temperature. Means you have to maintain the reaction condition and in a optimum reaction condition by keeping these parameters, appropriate parameters at a definite reaction condition, and the rate of reaction, progress of reaction, or the monitoring of that reaction. And for monitoring of that reaction, how do we know whether this reaction is completed or it is incomplete, or it is the total amount of reactant get converted into product, or whether that reaction is incomplete, means the reaction completion in percentage, such as conversion of total reactant into the product, it means at 100% conversion, or maybe as 80% conversion, or 50% conversion. So that type of the progress of the chemical reaction or the monitoring of the chemical reaction can be controlled or can be identified or can be detected by using IR spectroscopy, and that's why the name is given study of progress of chemical reaction. So rate of reaction, whether the reaction is completed within, for the completion of reaction required 1 hour, half hour, 20 minutes, 10 minutes. So such type of the rate of chemical reaction also we can identify and we can measure by using IR spectroscopy. We draw the drop or 2 drop of mixture from the reaction mixture, run the spectra with the help of suitable condition, or what we can call it as with the KBr. Generally KBr means potassium bromide. When the spectra obtained, if your starting, let us suppose your starting compound has a cyclohexanone, and as we know that cyclohexanone theoretically the peak is appear around 17-15 per centimeter. That is a characteristic of that carbonyl group of saturated ketones, and after some time when you withdraw the sample from the reaction container, again take the spectra. If spectra shows 2 peaks or 2 bands, one around 17-15 and another around 2500 to 3600 per centimeter, clearly suggests that the reaction is still incomplete. because the spectra producing two peaks, which suggests that the reaction is incomplete. Suppose again you withdraw after 1 hour, withdraw the sample, 1-2 drop of sample from the reaction mixture, again run the spectra or take the spectra, and by interpreting the spectra you can observe the appearance of peak around 2500 to 3600 per centimeter. Only one peak is observed. Recognizable peak or distinct peak appear around 2500 to 3600 per centimeter, which clearly indicate that the reaction is finished or the reaction is completed or reaction is completed. And the band which initially appear around 17-15 per centimeter, which is absent in the finished product or in the final product or in the final stage. And from that, in this way, the study of progress of chemical reaction, which is helpful in identifying the completion of the reaction. Let's see here, IR spectroscopy is often used to follow the progress of chemical reaction. Means IR spectroscopy is often used to follow the progress of chemical reaction. And the study the kinetics of various chemical reactions. To follow the chemical reaction, another one to study the kinetics of chemical reaction. Kinetics means the rate of reaction is very prominent or the important one. The rate of reaction, whether it is occurring, rate of reaction is a faster or the slower. If the reaction is very fast, we cannot determine how much time is taken for the completion of the chemical reaction. But if there is RDS, means a rate determining step, the reaction rate is a very slow, and if the reaction rate is a slower one, then we can easily determine or we can easily measure how much time is taken for the completion of given chemical reaction. There are different chemical reactions: substitution reactions, oxidation reaction, reduction reaction, elimination reactions, addition reactions. These are number of chemical reactions occurring depending upon the nature of the reactant and the reagent added and the other parameters such as temperature, pressure, whether it is applied for the reaction to occur. So that type of the study is there in the study of chemical kinetics, and these applications are based on the fact that most chemical reaction involve changes to functional group. As I already told you that functional group means site of reaction. The changes are occur at a particular part of the organic compound. Other part of the organic compound remains as it is. There is a no change occur, only changes are observed at a specific part of that organic compound, and that part or that site of that part of the organic compounds are generally referred as functional group. And this helps us to follow up a course of chemical reaction. A sample of the reaction mixture is withdrawn. I already explained this point, but let us see what is given over here. A sample of the reaction mechanism is withdrawn and IR spectrum is recorded. Understood this one? A sample of the reaction mixture is withdrawn and IR spectrum is recorded. The spectrum is used to determine how far the reaction is progressed and whether it is proceeding by expected pathway or not. This can be elaborated with following examples. Let us see here. Number 1, oxidation of cyclohexanol to cyclohexanone. First point, we are oxidation of cyclohexanol to cyclohexanone. Oxidation of cyclohexanol to cyclohexanone. Now as we know that the structure of and if you see there, oxidation means what? In terms of the organic chemistry, it is generally defined with respect to the hydrogen atom. The removal of hydrogen atom is known as oxidation reaction, or addition of hydrogen atom is known as reduction reaction. And there are different oxidizing reagents which can remove the hydrogen atom adjacent from vicinal atoms, and the resulting compound form, which is known as oxidation reaction. And here generally, first of all, you must know the structure of